So we are the health group, and our job was to identify the health risks that would come when living on Mars and find solutions for them. The main risks that we found were radiation, which Elena will talk about, the effects of low gravity on the body, which Martin will talk about. I will talk about the effect of the dust, the Martian dust, on the Martians, and also mental health. And Jake will talk about developing medicines on Mars and how the doctors will work.
Hello, my name is Martin. Like Kate said, I will be talking about the effects of low gravity on Mars. The first thing that will be affected is the muscles and bones of us humans. Our body might naturally adapt to the Martian environment. First, there was a question from one of the board members, one of the judges, and this, we looked into it. Our body will lose bone and muscle mass and density quickly on Mars. In fact, it's an average of 1% per month for the average human in microgravity and on Mars. Your point of that a human will eventually adapt to the environment is only viable in the future when the human has time to evolve on Mars. In the early stages, this deterioration and muscle atrophy can cause a high risk of fractures and a high risk that your bones will actually get broken really easily, and will also affect the amount of blood that circulates around your body, since the blood vessels are contained inside the bone marrow. This can be prevented by continuous exercise and also by consuming a calcium-rich diet. The next thing that low gravity will affect is the headward shift of fluids. This will happen due to microgravity, since fluids will move upwards. The effects of this are mainly cardiovascular issues that will be caused due to not enough blood going back to the heart. The countermeasures that you can take are lower body negative pressure, which would force the blood back down, vasoconstrictive tight cuffs, which are basically cuffs that you can place to limit the amount of blood that will rise up to your head eventually, and also anticoagulants, which are types of medicines that can help when a large amount of blood collects all in one area, and therefore with these medicines the blood won't clot. Another topic I will be talking about is the nervous system. The nervous system will experience various changes on Mars due to the difference in the environment between Earth and Mars. These include cognitive impairment, motor skills issues, and mental health disorders. This can be solved due to various neuroprotective therapies and also radio wave therapies. I'll be passing on the mic to Elena to explain radiation.
Hello everyone. Now, on Mars, radiation is a big problem. Why? Because there's no magnetic field. On Earth's core is a liquid, a very hot one in fact, which causes convection currents in the Earth's layers. Now, unfortunately, Mars's core has cooled down over time, so these convection currents have slowly reduced, and this magnetic field has slowly diminished. So, no magnetic field, no protection from radiation. Now, some short-term effects of radiation are nausea, fatigue, skin damage, and immunity problems. And in the long term, you can acquire high cancer risks, cardiovascular issues, and DNA damage. Now, here are some short-term solutions for radiation. Firstly, boron nitride radiation shielding suits. Infrastructure has already mentioned this material. It causes high radiation resistance as it absorbs small neutrons in the environment. Bless you. And luckily, this compound can be produced on Mars. Secondly, vitamin C and E. Due to their antioxidant properties, they can give someone low radiation resistance. Our next solution is amifostine. In pill form, this medicine gives the cells a coating, giving them more radiation resistance. And finally, potassium iodide. Currently, potassium iodide is used for cancer patients. When patients are undergoing radiation, this compound is given as it replaces radioiodine. Now, unfortunately, this compound has not been applied to solar radiation yet, but hopefully after further research and development, it will. Next slide, please. Now, a more permanent solution. Look at our little friend there, the tardigrade. It's an 8-legged, segmented microanimal, which can survive virtually any environment. In fact, it can survive 500 to 1,000 times the lethal dose of radiation for humans. Tardigrades have produced this protein called DSUP, which physically associates with DNA to protect the genes from damage, to protect the cells from damage. If we can locate which gene produces the DSUP, we can use CRISPR, as the technology team said, to edit this gene into the human genome. This is quite a costly solution at $1 million per person, but this price would be for a lifetime. Now, if you are really insistent on not being related to this cute animal, I honestly would like to be related to it, but oh well, you can, luckily tardigrades produce another protein, TDP1, which helps repair double-strand breaks. On the market, 1 milligram of this protein is being sold for 2,700 milligrams. Wait, $2,700 per milligram. We could give this protein as a vaccine. Now, since we haven't used this protein for radiation, we may need a second dose further on. Now, on to Kate for Mars dust and mental health.
So, in Mars, there is a lot of dust which contains harmful substances like perchlorates, heavy metals, and sharp silicates. These can potentially cause cancer in humans. So it's important that we prevent humans from inhaling these substances. This can be done by ensuring that it does not enter the habitats, and that when Martians exit the habitat for exploration outside habitat, they wear a spacesuit fitted with filters to prevent them from inhaling it. And when entering the habitat again, they pass through a chamber which has electrostatic strips which attract the dust, and also magnets to attract the heavy metals. And the Martians might also feel homesick because they start missing Earth. So together with the infrastructure team, we decided to create green areas where they can go, which would remind them of the Earth environment so they can enjoy the greenery. Also, we're thinking of giving them AI companions Since direct communication, real-time communication won't be possible between Mars and Earth, they can be given AI companions so that they can have friends with them all the time. We can also create recreational areas where they can practice their hobbies and take advantage of the lower gravity and create Martian sports, which would be fun to watch and also take part in. And also we can make sure to give them good and nutritious food.
So I decided to touch a bit on the topic of AI as well. So basically, in the past few years, NASA and Google collaborated on a project to create what is called a clinical decision support system. Basically, what this does is it is a tool that helps astronauts who are on the space station or any other type of rocket in order to help them with their medical needs at that specific time. So this tool is trained on spaceflight literature, and it provides real-time analysis of the crew's mental health. Now, the tool is designed to support medical professionals, but maybe over time, it can be developed into just using the tool itself and not anyone else being involved with it. So next I'll talk a bit about how vaccines can be produced on Mars. So the vaccines will be created in special facilities, and the infrastructure has already worked on that. So the basic ingredients in a vaccine will be a part of the virus, which is either dead or weakened, adjuvants, which improve the immune response to the vaccine. Now, an example of an adjuvant is an aluminum salt, whose ingredients can all be found on Mars. Similarly, for stabilizers and preservatives, they can also be found on Mars. So for stabilizers, they keep the vaccine stable and effective. An example of this is gelatin, which can be extracted from collagen, which can further be extracted from bones of any type of animal. So, and an example of preservatives help the vaccine last longer, and an example is thimerosal, which similarly to the adjuvants, its ingredients can also be directly found on Mars. So, and I'll talk a bit about antibiotics as well. So, antibiotics, on a basic level, are created by bacteria when they ferment. So, some of the microorganisms that are used are penicillium, which is a fungi, and streptomyces. So the basic process of how bacteria create these, or microorganisms create these antibiotics, are first inoculation, fermentation, harvesting, and purification. So taking an example with penicillium. So naturally, penicillium will create penicillin, but it can also be placed in fermentation tanks in order to grow faster. The penicillin is then extracted and purified to be made into an antibiotic form and medicine form. Now, a source of penicillium is decaying vegetation. Now, technology said that we shouldn't waste anything, and the same goes with food. Even though the food being provided storage, they might still decay over time. So we decided to still have a use for it. And streptomyces also come from poultry manure. Now, poultry is also provided by the fooding, and so we decided that this bacteria could come from this source. So I'll pass over to Ella now.
To conclude, we are so close to getting to Mars, but unfortunately, as time passes, new health problems will always arise. Hopefully, if we follow the developmental trend we are currently following, we will produce the tech to combat this. Who knows, maybe even after further research and development, we may even come up with an indestructible human. All we know is that whatever advancements we make, we get one step closer to the Martian dream. Thank you, and we hope to see you there.